then there's a 6-to-1 mole ratio. So moles of glucose times 6. This number comes from the balanced chemical reaction equation. Every mole of glucose in the denominator will produce 6 moles of water there. And that's why the moles of glucose times 6 divided by 1. You cancel out the glucose there. Each mole of water weighs 18 grams. And you get 63 grams of water produced from burning all these 105 grams of glucose there. So that's the calculation we need you to be able to do. And when you do calculations, when you quantify chemical reactions there's always another issue we need to look into. Assuming you have 105 grams of sugar and you take in, you burn it, and your body burns it, and you end up with 65 grams of, what's that, 63 or 65? 63 grams of water there. So we always need to be concerned about the yields. Theoretically, how many grams are you supposed to get? And experimentally, what is the actual yield? Now you know when you do the experiment. Yesterday you had some first-hand experience here. The crucible drops. You probably saw me doing the demonstration covered broken in the lab there. Okay, and chemicals spilled. So when you produce things through a chemical reaction in the laboratory there, it's not always you're going to get. It's not always going to happen that whatever you start, you're going to end up with the theoretical amount. So theoretical yield is the maximum product that can be expected based on the stoichiometry of the chemical reaction. Now, when you do chemical reaction in the lab and human behavior and human factor involved in there, the actual yield may be smaller. More than often, it is going to be smaller. Okay? So the actual yield is the experimentally measured quantity, how much you actually got. Now, the percent yield, we use this. This is different from percent error calculation. Now, you've been doing percent error calculation in the laboratory there. Percent error, by definition, is the difference between experimental value and the true value or accepted value divided by the true value times 100. Well, percent yield is how much you actually got divided by how much you're supposed to get. Okay? So these three terms is something that we need you to know. How we define theoretical yield, how we define actual yield, and what is the percent yield. Percent yield is actually a factor that we can use to evaluate how efficient the production is. Okay, so the equation, this is the equation that we need you to M word memorize. Okay. Searching of that M word there. You need to know this equation. How we define percent yield. This is the definition of percent yield. Now, chemistry, some of you may think it's boring. Now let's try to understand this through something that we all like, popcorn. Okay, you start with 20 kernels. Theoretically, you're supposed to get 20 popcorn. But you know what happens. Every time you put that bag in the microwave oven, when you finish, you take it out. There's always some on the bottom, never pop. So you start with 20, you only end up with 16. 16 is your actual yield. 20 is your theoretical yield. The percent yield, 16 divided by 20, 80%. 4 did not pop. So that's what this is all about. That's the chemical reaction here. When you heat it up, you provide energy there, and chemical reaction happens. Okay? So that's how we want you to understand the idea of theoretical yield. And when you start with 20 kernels there, you're supposed to get 20. But more than often you don't. So the ratio between what you actually got versus what you're supposed to get times 100 percentage number, that's the percent yield. We will ask you to calculate percent yield of a chemical reaction. Now that we know how to quantify a chemical reaction based on the molar mass and based on the molar ratio and based on a certain amount of chemicals that you have there. So the calculation involving the percent yield and theoretical yield. Well, this is an example there. Can't believe I didn't type the answer in there. And so if the metabolism of 670 grams of glucose will produce 403 grams of water, and the amount of water produced in the lab is only 385. The question is asking you, what's the percent yield? Well, this is like who's buried in Grant's tomb. Well, unfortunately, all the questions that you will be seeing is a little bit more complicated than this. So theoretical, actual divided by theoretical times 100, 95.5%. Okay, so that's one example. That's probably why the reason why I did not hide the answer there, because it's that straightforward. You divide the two numbers by one another, multiple, convert it into a percentage number there, you get a percent yield. Let's try something different. Assuming you're doing a chemical reaction, you're trying to make pure copper in the laboratory there. Okay? You have 1.274 gram of copper sulfate containing copper ion. You react it with metal zinc. When the chemical reaction is finished, you obtain 0.392 gram of copper. We ask you to calculate the percent yield. Well, in order to calculate the percent yield, we have to know how much we're supposed to get. Okay? So we got to figure out 1.274 gram of copper sulfate. How many grams of copper are you supposed to produce with that quantity? So this is a stoichiometry question or dimensional analysis. So we start with 1.274 grams of copper sulfate. We got to convert it into moles first, because there's no direct relationship between the mass of copper sulfate to the mass of copper. Okay. Now, each mole of zinc sulfate of copper sulfate is equivalent to, well, you got this number yesterday when you're doing water hydration. We did ask you to do the calculation for converting the grams of copper sulfate to moles there. So you did that in the lab there, 159. If you end up with anything other than 159.6, 0.5.6, check your calculation. Okay, so gram and gram cancels out. That will give you the number of moles of copper sulfate. And the molar ratio between copper sulfate and copper is that each mole of, that's the balanced chemical reaction equation, by the way. Each mole of copper sulfate will produce 1 mole of copper. And each mole of copper is 63.546 grams. So this is the setup to figure out the theoretical yield. Starting with grams of copper sulfate, ending up with grams of copper. Do we end up with grams of copper? Well, we can see. Cancels out. Cancels out. What's left is the gram of copper. So this is a calculation involving 3 different dimensional analysis. You can do them in 3 individual steps, or you can set everything up in one equation. 1.274 divided by 159 times 63. That will give you the answer. Okay, so that's the answer. That's how many grams of copper you're supposed to get. That's Ty, theoretical yield. Percent yield, you only got 0.392 grams. So 0.392 divided by 0.50, roughly about 77%. Okay, so this is a type of question that we need you to be able to do. Quantifying chemical reaction equation based on the balanced chemical reaction equation, based on the amount of chemicals supplied. And you need to be able to do